I'm gonna go ahead and start recording eyes. Let's go through the problems here. I'll clean up my screen a little bit. All right, talk to me about the first one. What can I do on number 11 here? How would I approach that? Yeah, basically the same thing. Yeah, we have logs with the same base on either side. These from different bases, I couldn't use this trick, but because it's log with the same base on each side, those are basically going to cancel out. And so we have x plus 10 equals 8 minus x. Where to from here? My like terms together, so I'm going to add x to both sides. And I'm going to go ahead and subtract 10 from both sides also. So I end up with 2x equals what? 2x equals -2, so x is -1. Right. So there's the first one, and I heard some lively conversations that I loved on number 12. How should I begin approaching this problem? What should my first tool be here? How do I want to approach it? Rewrite into log form. I want log with base of what? A log with a base of e. So I'm going to have natural log of e x ln 3 equals natural log of 27. What do you notice about the left-hand side that I can simplify? So the ln and the e right here, this is basically equal to 1. And so it is just going to cancel out. I'm going to be left with x natural log of 3 equals the natural log of 27. My goal in this problem is to isolate what? X. How do I get x by itself? Divide both sides by the natural log of 3. Did anybody get it this far and then pop it into their calculator? X equals 3. Let's talk about why this came out so nice and pretty. So we had x equals the natural log of 27 over the natural log of 3. What do you notice about those logs on both sides? They're not going to cancel out because log is not multiplication. It's a different operation altogether, but I like what you're thinking because it does have this special property when I have logs with the same base on top and bottom. We'll probably get into digging into this more tomorrow, but this is what it looks like when I apply the change of base property. When we have the change of base property, this argument right here is my original argument. And this down here is the base. So what this is saying is that I would have log base 3 of 27. Is that something that we can evaluate without a calculator? Yeah. 3 to what power gives me 27? 3. And that's exactly what we found when we used our calculator and we did log 27 over log 3. Sorry, not log, ln 27 over ln 3. Right. Like I said, we'll talk more about change of base probably tomorrow. I don't think that we'll get there today. Go ahead and hop into that new notes packet. You should have picked 2 things up at the beginning of class, one with a staple and one without. We want the thing that has a staple with it first. The thing without the staple is for you to work on your own. I'll give you guys the answers tomorrow. I'll also post all my work tomorrow. That is to help prepare you for your quiz, which is on which day? Wednesday this week. 5-4 and 5-5. We covered 5-4 completely before break. We're going to cover 5-5 today, and we'll finish it up tomorrow. Quiz will be Wednesday, first thing at the beginning of class, and the 5-5 homework is due Wednesday night. After that, we have one more section to cover. Wednesday after your quiz, I will give you guys the review for the test is a week from today. So it's next Monday. All right. Let's talk about our properties for laws and logarithms. We're going to talk about expanding and condensing today. If I have a log, the base of, say, b, and my argument contains a product, we'll say x times y, I can rewrite that in its expanded form as two separate logs, where each piece of that product becomes an argument all by itself. Can anybody think of what the analogous property with exponents is? Like, what is this based on when I think about exponential? That's exactly right. So if I had 2 to the x times 2 to the y, I would be adding those exponents together. That is exactly what this property is based on right there. My quotient property. I have a log with base b. My argument is a quotient, x divided by y. Think about exponents. When you have the same base top and bottom, what do you do with their powers? Yes, we're going to subtract here. Log base b of, it'll be your numerator first, minus log base b of your denominator y. Notice it was a single log. I did not have a log on top and a log on bottom. It's log of a quotient. I have a quotient as my argument. And then the last property that we're going to talk about here is the powers property. If I have log base b of x to the power of w, I can bring that power down in front as a multiplier on my log. Hopefully all of this is familiar. You might have struggled with it the first time around, but hopefully all of this is something you guys have done before, correct? Yes. Power property we've actually kind of already been using. We just used this on the previous problems. You guys remember how we said that the natural log and the e canceled out? This is the property that was going on in the background. We just hadn't clearly defined it yet. All right, I want to use our properties here, mainly the power property, to look at evaluating these next 3 logarithms. Then we're going to practice with expanding and condensing. So on number 1, I noticed that we have a 4th root. What's another way to write a root? A fractional exponent, yes. If I have a fraction, that would be a negative exponent. If I have a root, that is a fractional exponent. So I can rewrite this as log base 5 of 25 to 1/4 power. And now that I see that 1/4 power, how can I use the powers property? It can come down to the front. That 1/4 is going to come down as a multiplier in front of my log. So 1/4 times log base 5 of 25. Can we evaluate log base 5 of 25? What is log base 5 of 25? 2. So I have 1/4 times 2. What is 1/4 times 2? 1/2. Or if you wanted to write that as a decimal, it would be 0.5. Number 2, how can I rewrite this so that I can use my powers property? Yes. 3 log base 7 of 49 to the 1/6 power. And then that 1/6 I can do what with? Drop it down in the front. Does it matter whether it goes before or after the 3? They're going to be multiplied together. Talk to me about what you know about multiplication. Does order matter with multiplication? Nope, it is commutative. It can go either way. So it doesn't matter whether you drop that 1/6 in between these two or in front of the 3. It's going to come out exactly the same. What is 3 times 1/6, by the way? 1/2. 1/2. So over here, I multiply these two together, I get 1/2. And can I evaluate log base 7 of 49? That's 2. So this whole thing evaluates 2. 1. Number 3. What can I do here? Yes, I would move the exponents to the front first. Technically, that's the natural log of the square root of e. That's confusing, but I can drop these powers down. So I have 0.5 times 36 natural log of e minus 5 times 4 natural log of e. And that 4 is being multiplied to the natural log of e. The 36 is being multiplied. When you see it down in the front, that's just a multiplier there. Natural log of e evaluates to what? 1. A lot of times you'll see professors write it like this and then say, oh, that just simplifies to 1 right here. And that's getting multiplied. Let's see, 0.5 times 36 is what? So 18 times 1, so I have 18 minus 5 times 4, 20. 20 times 1 is just 20. So 18 minus 20, -2. You guys have any questions about using the powers property to simplify and evaluate? Next thing we're going to move on to is expanding. So when I'm expanding using properties of logarithms, I'm going to take something that looks like the left-hand side over here, and I'm going to rewrite it into something that looks like the right-hand side. Usually I go looking for them in this order. I don't have to see each individual step written down. If you guys can look at it and fully expand it in your head and write it down, that is totally fine by me. But as I'm looking at these to make sure that I put all the pieces, I usually go looking for my quotient property first. Then I go looking for the power property, or sorry, product property. And last, I do my power property when I'm expanding. So on number 1, do you see the quotient property at work? Yes. So I'm going to do these first couple step by step, and then after that, we'll get into doing them all just in one piece. So I would have log of what? What would come first? Log of 5. Quotient property says my division turns into subtraction. Division turns into subtraction. Common log of x to the 4th. Do you guys see the product property at work anywhere? Inside the arguments, do you see two things being multiplied together, two or more? Nope, I don't. What about Powers property? That one I do see. We have an exponent of a 4 right here. I'm going to drop that down in the front. And that will complete my expansion here. So I'm going to have common log of 5 minus 4 times the common log of x. My final fully expanded answer there. On number 2, do you guys see the quotient property at work at all? No quotient property. What about product property? Yes, I see products right here. And when you see multiplication, when the product property is at work, we're going to change that to what? Addition. So log base 3 of 4 plus log base 3 that's y to the 8. Fully expanded? No, I still apply what property? Powers, yes. I be doing the same thing. Screwing up those two words. All right, so I have log base 3 of 4 plus 8 log base 3 of y. Fully expanded. I want you guys to do number 3. Fully expand that one. Take about a minute. What does number 3 look like fully expanded? What does this one look like fully expanded? Careful. 7 log, and I know it takes a little extra moment to say, but base 6. 7 log base 6 of x minus 4 log base 6 of y. Yes. Jumping right to that point, if you can do that, cool. I am not looking for work on expanding condensed problems. I will only be evaluating your final answer. If it helps to write down the steps in between, that keeps you from making mistakes, absolutely don't feel like you have to give that up. All right. Look at number 4. Do we see the quotient property at work here? Yes. Product property? Yes. In the numerator or in the denominator? Numerator. Powers property? Yes. Let's see if we can write this down in one single step. So I'm going to have log base 5 of what will come first? X. Plus 2 log base 5y minus log base 5 of W. Absolutely correct, fully expanded. Good question. Okay, I was asked about parentheses. Would parentheses be right or wrong? Parentheses would not be wrong depending on where you put them. Like if you look at your numerator and you're like, I want to make sure that I group those together, you could put parentheses around the pieces that came out of your numerators. That would not be wrong. It's not required. It's not necessary. It does not change your fully expanded answer. But it's not wrong to put the same. Where you would want to be careful is if you see the product property at work in your denominator. Because if it came from the denominator, what's it got in front of it? It has a minus as subtraction. So if you see the product property at work in the denominator, you have to do one of two things. You either have to put parentheses around what came out of your denominator, and then you would see a plus in there, or you need to distribute that subtraction. Basically, if you see more than one term, or more than one variable, more than one piece in your denominator, when it's fully expanded, it needs to have subtraction in front of it. Every single piece that came from the denominator needs to have subtraction in front of it. If it is positive or has a plus sign in front of it, you're telling me that that was originally part of the numerator. So let's kind of look at this and we'll look at something like what you were asking about there in just a moment. Number 5. Do I need to worry about more than one minus sign on number 5? No, why not? Just one variable down in my denominator. Let's write this one out. So natural log of, what will come first? Natural log of 3. And then what? Plus natural log of W. The 2 has to go in front of the natural log, yes. And it has to go in front of the natural log of X. Because the 2 was an exponent only on the X. It was not on any of those other pieces. Yes, minus 4 natural log of Y. Beautiful. Can you put parentheses around your arguments? Yeah. When it's fully expanded, you usually don't need to. Usually we have to really watch parentheses and stuff if we're condensing around things. How many variables do I have going on in the denominator on number 6? 2. I have Y and I have W. So fully expanded without parentheses would mean how many subtraction signs? 2. Go ahead and write this one out. Common log of what? Common log of 9. Plus 5 common log B. Plus common log of X. Minus 2 common log of Y. Minus 4 common log of W. Yes. Now, on a problem like this, could you have chosen to use parentheses? Yes. If you are used to doing it this way, I would not count it as wrong if you had parentheses around these last 2 pieces, but if you did that, then that would need to be a plus there. Because those 2 things are being multiplied in the denominator. So if you have a minus in front of parentheses, and then you've applied the product property, that would be okay. Okay. I personally find this way easier because when I look at it, I'm like, oh, minus, minus, you came from the bottom, and I can check it very quickly. Number 7. Ugh. We've got parentheses happening here in number 7. What should I do first? Multiply the 2x by what? They're already being multiplied. Multiply by 2x by 2x, we can absolutely do that. I'm gonna kind of write this off to the side. Because I want to look at two different ways of approaching this. If I do 2x times another 2x. Yep, or 2 squared x squared, right? Because that's 4x squared. I have a reason for writing it this way, so just hang with me for a minute. All right, so assuming that I took this original problem just the way it was, and I apply the product property, I would have log base 6 of 2x squared plus log base 6 of y to the 5th. Oh, sorry, I put my square in the wrong spot.
Yeah, it's gonna go out.
Yep, it's outside, thank you. Normally after this, because of those parentheses, I would be applying my powers property. So I would have 2 log base 6 of 2x plus 5 log base 6 of y. But that exponent, the squared, was applied to both the 2 and the x, right?
Yeah.
So when I go to use the product property on that first term, I need 2 log base 6 of 2 plus 2 log base 6 of x.
Well, I don't have hearing, not very.
Yes, I am.
Not very. But,
All right, so this would be fully expanded on number 7. If you apply the product property after applying the powers property, because the power was outside of the product, it has to go with each piece of the product property. If you did it this way from the beginning, you can see why the 2 is in front of here, because that would be 2 squared. 2 squared. This would be x squared. X squared. Yes, ma'am.
So is that the same as 4 log base of 6 plus 2 log base of 6?
So it could be 4 log base 6, because you always have to have an argument, but it would be the same as log base 6 of 4 plus 2 log base 6 of x.
Oh, yeah, that's what I.
Yes, yeah, as long as the 4 is your argument and not a multiplier, because a log always has to have an argument. A log always has to have an argument. You always have to have something after the log. Otherwise, it's like saying times. You're like, times what? You're like times. Or add. Add what? Add. You have to have things that you're doing this to. So I heard something about the difference in 2 squares here on number 8, and I love this little side conversation that I heard going on. Where is our difference in 2 squares? In the denominator. So let's go ahead and rewrite that. I love that you saw that first, because if you miss that piece, you still have to go looking for it, but you have to look for it at the end. Can I rewrite that numerator in any which way? Yes. The 1/3 power, absolutely. Okay, so I have log base 5. Up on top, I have x squared plus 1 to the 1/3 power. In my denominator, I have x plus 1, x minus 1. Can I cancel? No. Because I do not have an x squared plus 1 on the bottom. Can I factor x squared plus 1? No, it only has imaginary roots. That is the parent quadratic shifted up one. So it does not ever touch the x-axis. It is unfactorable. So what can I do with this then? I want to expand it. The 1/3 is going to go to the front. Okay, so let's write that down. 1/3 log base 5 of what? X squared plus 1. And then what? Minus log base 5 x plus 1 minus, why minus again? Because where is it? It's in the denominator. The other factor is in the denominator. Janie, you could write it with a plus if you stuck parentheses. Write up your minus sign and then again at the end.
Yeah, parentheses for x plus 1.
Yes, yes. So here, let me show you the other way that this could look and still be correct if you wrote it as a plus using your product property. Oh, that should not be 1/2, that should be 1/3. 1/3 log base 5 x squared plus 1 minus, and then I'm actually going to use a bracket here so I don't have too many sets of parentheses going on. Log base 5 of x plus 1 plus log base 5 of x minus 1. If you wrote it like that, as long as you have the brackets around it so that you are saying this whole group that comes after the minus, that all came from my denominator originally. Either one of those would be fully expanded. Go ahead. And I believe you have to turn the page to get to the next couple problems. We're going to go the other direction now. We're going to get as far as we can with condensing. We'll pick up wherever we leave off first thing tomorrow morning. So condensing, I prefer this direction. I hate taking up more and more and more paper. I like condensing because we're going to take it from a big long thing down to a small little smashed condensed piece that takes up a lot less paper. And that makes my little simplifying now part so much happier. All right, so anything that's down in front as a multiplier, I'm bringing up as a power, and I do that first because I do this in reverse. I look at it first for powers, then for product, and finally for quotient. So I would have log base x squared. Sorry, not log base x, common log of x squared plus common log of y to the 7th. And then I can apply my product property. Whenever I see a plus, what happens in my argument? Becomes multiplying. So log of, I'm going to pop some parentheses on here, x squared, y to the 7th. Technically, because there's no pluses or minuses in there, I don't have to have the parentheses around my argument, but I tend to find that I make fewer mistakes if I do that. The whole reason that we use expanding and condensing is because when we're working on more complicated problems, this becomes another tool that we have to simplify and evaluate pieces. So if I am condensing pieces together, I want to make sure that I'm getting them fully simplified before I call it all the way done. Right. Here on number 2, they left that similarly to the second way that I wrote that. How many pieces are we going to have in our denominator? 2 pieces, 2 variables. We're going to have an x and a y. I see that we're going to have some exponents. So just kind of going through what my mind would be doing here. I would have log base 5 of z to the 6th minus, and then I would condense this piece down using my product property. And I see that addition right there. It's gonna be log base 5 of x to the 7th, y to the 8th. Technically, I don't need those parentheses around these people. So I did two things in one step. I used my product property here. I did not understand the color on that. No. And I used my powers property. Fully condensed yet? No, I still have a subtraction in there. Log base 5 of what? Z to the 6th over x to the 7th, y to the 8th. Now it is fully condensed. Talk to me about this. What's going to happen with that first? Yeah, it's going to become a square root. So this right here would be log base 3 of 6x minus 5 to the 1/2, which is the exact same thing as the square root of 6x minus 5. So when I finish condensing this one down, am I using product or quotient property? Quotient. Talk to me about my numerator then. Numerator is 4. Denominator? Square root of 6x minus 5. If you left that as 6x minus 5 to the 1/2 power, that would still be fully condensed and that would not be wrong. All right, let's stop there for today. We'll do number 4 and number 5 along with the rest of the condensing problems first thing tomorrow. And then we'll talk about change of base formula a little bit more in depth. Please make sure that you're working on the review. If there are pieces that you don't know how to do on the review yet, that's okay. You will know at the end of class tomorrow. You should be able to do all of it, if not, but maybe one problem or possibly two. I will go over the answers tomorrow at the end of class. I will also post all of my work on Canvas tomorrow, so you guys are fully prepared. That is on Wednesday.